Okay, let's just dive right in. I mean, we've all seen this absolute explosion of AI tools lately, right? From ChatGPT to all those crazy image generators, it really feels like we're living through a massive shift in technology. But what's the actual engine driving this whole revolution? Well, it's a concept that most of us probably haven't even heard of, even though we're already using it every single day.
So we know these new AI tools can do some pretty incredible creative things. You can ask one to write a poem about, I don't know, a lonely sock, and boom, in seconds, it'll give you something that's actually kind of touching.
But here's the wild part. That exact same piece of technology can turn right around and handle something super practical and complex. It can map out your entire week-long vacation. We're talking flights, hotels, daily activities, the whole shebang. So it's a poet and a project manager, all in one.
That incredible range, from the purely creative to the super analytical, it just begs the question, how can one single technology do so many different things and do them so well? What is the fundamental idea that makes all of this possible?
To answer that, we have to understand that we're not just looking at a slightly better version of old AI. No. We are looking at a completely new paradigm, a whole new way of thinking about and building artificial intelligence itself.
So think about it like this. The old way of doing AI was really specific. If you wanted an AI to analyze customer reviews and another one to translate German to English, you had to build two totally separate, specialized models from the ground up. One model, one single task. The new approach? It's completely different. You build one enormous, powerful base model, a foundation model, and then you just adapt that one model to do both of those tasks, and hundreds more. It is a total game changer. And that brings us to the term itself, foundation model. This was actually coined by researchers over at Stanford who saw this massive shift happening. And the name is just perfect, right? Think of it like a shared backbone, or maybe a super versatile engine that you can just plug into all sorts of different applications instead of having to build a brand new engine for every single car. Okay, so if these models are so powerful and so flexible, how on earth do they learn? Well, the process is actually pretty intuitive, even if the scale is absolutely mind-boggling.
They are trained on these colossal amounts of unstructured data. We're talking huge chunks of the internet, books, articles, you name it. And their main job is surprisingly simple: prediction. The model is constantly just playing a game of fill in the blank. So if it sees the phrase, "no use crying over spilled blank," it learns from trillions of examples that the most likely next word is milk. And by doing that over and over and over, it develops this incredibly deep understanding of language, of context, and even a form of reasoning.
Now, after that initial, huge training phase, that's where the real magic happens, the adaptation. You can fine-tune this general model by feeding it a much smaller, more specialized data set, like say a bunch of medical journals, to make it an expert in that specific field. Or even simpler, you can use prompting. And that's what most of us are doing with tools like ChatGPT. We're just giving it instructions in plain English to guide the model toward the answer we want. No new training required at all.
Of course, a technology this powerful isn't going to be simple. It brings with it some incredible advantages, but also some very, very serious challenges that we really need to be aware of.
So on the power side of the equation, the benefits are huge. Because these models have learned from such diverse data, they often perform way better than the old specialized models. They can generalize and spot subtle patterns that a narrow AI would just totally miss. And this leads to massive gains in productivity. Developers don't have to spend months gathering huge data sets anymore. They can just adapt a foundation model in a fraction of the time and, frankly, the cost. But then you have the challenges. And they are not small. For one, training a model like this from scratch is astronomically expensive. It requires these giant server farms packed with specialized computer chips. And then there's an even bigger issue: trust. Since they're trained on the wild, unverified internet, their knowledge base is full of biases, inconsistencies, and just plain wrong information. Making these systems consistently reliable and accurate is one of the biggest hurdles we're facing in AI today. Now, we've mostly been talking about language, right? Chatbots and text. But it is so important to understand that this whole foundation model idea is much, much bigger than that. The same core concept, build a big, adaptable base model, is now being applied far beyond just text. We are seeing it everywhere, in computer vision, in software development, and even being used to accelerate fundamental scientific discovery. Language was really just a beginning. In the world of vision, you've probably seen tools like DALL-E 2. Well, those are vision foundation models.
They've learned the connection between text descriptions and what images look like, which allows them to generate a custom picture of pretty much anything you can dream up, just from a simple text prompt.
In software development, tools like GitHub Copilot or IBM's Project Wisdom are foundation models trained on billions and billions of lines of code. They can suggest the next line of code you should write, complete entire functions for you, and even help you debug problems. They're dramatically speeding up the work that programmers do every day.
And this is where it gets truly profound. Scientists are now using foundation models to tackle huge global challenges. There's a model called MoLFormer that's helping to discover new molecules for targeted medicines. Other models, trained on geospatial data, are making our climate change predictions better. This isn't just about convenience anymore. This is about accelerating human progress.
So, what this all really means is that we're no longer building AI one brick at a time for every single little task. We now have this powerful, versatile, and yes, complex new foundation. It promises to transform entire industries, but it also comes with very real risks that demand our careful attention. The big question for all of us now is, what are we going to choose to build on it?